Welcome back. Today we have come with a problem from SFM Strategic Financial Management, and this is from Portfolio Management. This one problem covers the five areas: expected returns of individual securities, risk of securities, correlation and covariance of covariance between a securities, portfolio returns and portfolio risk, weight of minimum risk portfolio, what it could be. So all these five areas we are going to cover in this problem. Okay. Whenever we see a problem like this, we have to prepare a table which is x minus x bar the whole square. 1 minute. Yes. Okay. X minus x bar the whole square. Then another security is y minus y bar the whole square, and both the variance should be multiplied for the covariance. Okay, so x minus x bar the whole square, x minus x bar, sorry, not the whole square, y minus y bar, we have to multiply this. Okay, right. Yes, years are mentioned here: 1 2 3 4 5. What's the return of x? 10 percentage, 15 mention, 10 15 20 18 2. X minus x bar is its total this 10 plus 15 plus 20 plus 18 plus 2, which is 65. So what's the x bar? 65 divisible by summation of x divisible by n. So 65 by 5 is the average return. 13 is the x bar value. So 13, right? Now 10 minus 13 minus 3, 15 minus 13 2, 20 minus 13 7, 18 minus 13 5, 2 minus 13 minus 11, right? So we have to square root everything. 9 4 49 25 1 21. Total this up: 9 plus 4 plus 49 plus 25 plus 121, which is 208. Now we got the x minus x bar the whole. Now we have to find out the variance, which is summation of x minus x bar the whole square divisible by n, which is 208 by 5. How much? 208 by 5, which is 41.6 percentage square. What's this? What's the standard deviation? 41.6 square root, which is 6.45 percentage is the standard deviation. Now we have completed the x part. Let's go to the y part. Okay, what is in y? 15 percentage, 18, 17, 25. Okay, what's the total? 15 plus 18 plus 17 plus 20 plus 5, which is 75. Okay, now let's slightly move this. Okay, okay. So what is y bar? Summation of y divisible by n. 75 by 5, which is 15. 15 percentage is the average return. So 15 minus 15 0, 18 minus 15 3, 17 minus 15 2, 20 minus 15 5, 5 minus 15 minus 10, right? Everything we calculated 0 9. Let's square this off. 4 25 100. Now we have calculated the y minus y bar the whole square also. We'll sum this up: 9 plus 4 plus 25 plus 100, which is 138. Okay, sigma square is equal square is equal to 138 divisible by 5, which becomes 27.6%. Will square this root. Sorry, square is very important. We have to square. We have to put a square mark here. 27.6% square. Okay. Put this 5.25 is the standard deviation here. Right. Okay. Now what we have to do is we have to multiply the risk. Okay, x and y, what's the deviation we have to find out here. We have to find out. Okay, this part you should not take the wrong values. Okay, so minus 3 into 0 0, 2 into 3 6, 7 into 2 14, 5 into 20, 5 into 5 25, minus 11 into minus 10, which is 110. Okay, everything, these things will be in percentage square. Since these are in percentage, if you multiply the percentage, percentage will be percentage square. Okay, so 6 plus 14 plus 25 plus 110, which is 155 percentage square. Yeah, with this we have to find out the covariance. What's the formula for covariance? Sigma x minus x bar y minus y bar the whole square divisible by, sorry, this is not in square, the whole value will be in square. Okay, divisible by n. 155 divisible by 5, which is 31 percentage square. Root this out, we'll get 5.56 percentage as the covariance. With this one table, what are the information we got? We got the expected return of x and the risk of x, expected return of y and risk of y, and covariance between the x and y. So these much things we have completed with this one table, and we'll go to the next part, which is portfolio returns and portfolio risk. If investor decides to invest 60% in x and 40% in y, so okay, portfolio, expected return of portfolio. What's the formula for expected return of portfolio? Weight of x into expected return of x plus weight of y into expected return of y. Okay, what's the weight of x? They said 60%, which is 0.6 into expected return of x is what? Average, which is 13. Okay, what's the expected return of y, which is 15%? We are here, we are earning 15%, and what's the weight, which is 0.4, 0.6 into 13, which is 7.8 plus 0.4 into 15, which is 6. Total 13.8%. 13.8% is the expected portfolio return. Okay, what's the portfolio risk? When it comes to risk, we have to find out the we have to find out the correlation. Okay, by merging both the securities, how much reduction is reduced by each securities inside the portfolio. So why we are creating a portfolio? To reduce the risk. So how the risk get reduced? Between the variation between the securities. Okay, so let's find out the portfolio risk. Sigma p square, which is wx into sigma x into whole square plus wy into sigma y into whole square plus 2 into wx into sigma x, wy into sigma y into or xy. This is the correlation, right? Okay, using this, our risk, our actual risk we are going to find out will be reduced by the variation between the securities inside the portfolio, right? Okay, what's the weight of x, which is 0.4 into what's the risk of x, which is 6.45, that we have already found out. See, okay, plus weight of y, weight of y is 0.4, sorry, weight of x is 0.6, weight of y is 0.4, risk of y is 5.25 the whole square plus 2 into 0.6 into 6.45 into 0.4 into 5.25 into r xy. We have to find out the r correlation of xy. How to calculate the correlation of xy? We'll prepare here. Okay, what's the correlation between the securities? Correlation is termed as R, and it ranges from -1 to +1. Okay, what's the formula for correlation? Net risk divisible by total risk. What is net risk here? Covariance is the net risk, because by merging two securities inside the portfolio, we got the reduced risk, right, which is the net risk. So what's the net risk is 5.56 percentage. Okay, we'll get the actual figure, no, with before square of, which is 31 percentage square. This will be, what's the total risk? Total risk is the individual standalone risk of both the securities. We have to multiply. Okay, so total risk is risk of x into risk of y. Okay, what's the risk of x, which is 6.45 percentage into risk of y is 5.25 percentage. Okay, let's multiply this 6.45 into 5.25, which is 33.8625. So 31 percentage. So 31 divisible by 33.8625, which is 0.91 is the correlation. Okay, we got the correlation here. Okay, 915, which is, let's take 2. 0.92 is the correlation. Let's multiply this up. Okay, 0.6 into 6.45, 0.4 into 5.25, 2 into 0.6 into 6.45 into 0.4 into 5.25 into 0.92. Okay, I got the wrong values. 0.6 into 6.45, 0.4 into 5.25, 2 into 0.6 into 6.45 into 0.4 into 5.25 into 0.92. Okay, the portfolio risk is 34.34 percentage square. Let's square this off, which is 5.86 is the portfolio risk of this weights, 60% in x, 40% in y. If we invest in the portfolio with this ratio, the risk will be 5.86%. Okay, what else they have asked? They asked for the reduced risk portfolio. They asked us to find out the weights which is having a minimum risk with the minimum risk of the portfolio. Shall we find out? Shall we find that out? Okay, weights of minimum risk portfolio. Okay, how the risk is get reduced? Risk reduction of security is equal to standalone risk minus combined risk, which is covariance. Okay, now let's prepare the table. Risk reduction of security, we have to find out how much risk is reduced by another security for the security. Okay, then what we have to find out is what's the weight, how the weight is get calculated. Risk reduction of security divisible by total risk reduced with x plus y. Okay, that's it. Shall we calculate? Weight of x is equal to reduced risk reduction of portfolio. What's the variance of x? Variance of x is 6.45%, but that is the standard deviation. We have to take the actual variance, which is 41.6, 31.2, and these two values, these three values is required for our risk reduction of security calculation. Okay, now what's the risk of x 41.6% square minus 31% square, 41.6 minus 31, which is 10.6% square, right? What's the weight of y? Risk reduction of y, which is 27.6%. Okay, 6% minus 31% square, 27.6 minus 31, which is minus 3.4% square. Okay, yeah, we got the answer now. What's the total risk reduced? 10.6 minus 3.4. This is the total risk reduced. Okay, this is the value we are going to insert here. Now, what's the weight of x is equal to risk reduced by y divisible by total risk reduced. Okay, what's the total risk reduced by y, which is minus 3.4% square. Total risk reduced is 7.2% square. So 3.4 divisible by 7.2, which is minus 0.47% square. It will get cut, no? So no value should come. It is a weight we are finding. So here reduced risk of x 10.6 divisible by 7.2. What's the ratio? 10.6 divisible by 7.2, which is 1.47. So what's the weight here? Weight of x is 0.47 and weight of y is 1.47. This is the risk reduction ratio. If we invest the ratio at this point, now we'll get the reduced risk. That's it. Thank you.